To study area this year, I have made 3 videos, and they go together, and this is the first in a series. So the first one is the area of a square or rectangle. This one is new for grade 5s and is a review for grade 6s. The next one is, or the next video will be area of a parallelogram and a triangle put together, and that's for grade 6s only. The last video is understanding area for advanced minds. Hopefully that includes everybody in the class, and that's for grade 5 and 6. Now, for this video, we're looking at the first one, area of a square or rectangle. As always, we want to begin by looking at a big idea for area, and I found this in a book. The area of an object is a two-dimensional attribute. Okay, I want you to remember that area is a two-dimensional attribute. We'll talk about that more as the lesson goes on. For example, the number of square units it takes to cover a shape on a surface of an object. Area can be a single measure of a 2D shape on an object or a combined measure of a 3D shape like surface area. We're not dealing with surface area right now, but I want you to keep in mind that area is the measure or is a description of a two-dimensional attribute. Those two dimensions are length and width. Let's get started with some simple examples. So here are two, well, one's a rectangle and one's a square. Now, I used a grid background, but the rectangles are on top, but you could see that the length is 9. So there are 9 squares from here to here, and there are 4 squares from here to here. So again, I can use a formula that area equals length times width. I can multiply that and substitute the length and the width as 9 and 4, and I get my answer of 36 centimeters square. Let's look at another example. So here we have a square, and the square has a length of 6 and a width of 6. And it's a square because the length and the width are the same number. So once again, I can write the formula that area equals length times width. I can substitute the numbers, and my answer again is 36 centimeter square. That's interesting that I got the same answer even though that the dimensions are different. I want you to keep that in mind. Let's look at this question, and it's asking us to draw a diagram for a rectangle that has a length of 12 meters and a width of 3 meters. So here's my rectangle, and again, you could count the squares to find area. I can use my formula that area equals length times width. I can substitute numbers, that 12 times 3, and again, 12 times 3 we know is 36 meters square. Let's look at that rectangle again. So we already know that this rectangle has a length of 12, a width of 3, and that the area is 36 meters square because we already solved the area for this rectangle. We can use an array. So over here I drew a model with arrays. Now, we used to tell kids to draw arrays if they didn't know their multiplication tables, but it actually goes very well with area. So there are 12 circles going across, and there are 3 circles going down. So this array has 12 circles going across and 3 going down. And you can count the circles and know that there are 36. But also keep in mind that the first row is 12 times 1, and the second row is 12 times 2, and that the last row is 12 times 3. And that's an excellent way to represent and understand an array. Let's look at this problem. So this time it gives you the area of a room being 16 units square, and it asks you to draw diagrams to find the lengths and the widths. So we'll draw some quick diagrams, and the first thing I know is that I can do a diagram like this, and this is a very narrow room because the length is much greater than the width. So that's one possible dimension of the room, that the length would be 16 and the width would be 1. Okay, I can draw another rectangle. So this time it would be 2 units by 8 units, right? And then finally, I can draw another room, and this room would be a square because I know that 4 times 4 would give me an area of 16 squared units. Here are those same shapes drawn with more precision. In fact, you can even see the squares in the middle. So I made sure that I counted out 16 squares here and the width of 1. So if you count the squares, there's 16. Just like if you count the squares here, there are also 16. Okay, and if I count the squares here, there's 4, and it has a width of 4. So all of these shapes have an area of 16 squares. And if we think of multiplication, that means that 16 times 1, we know that 16 times 1 is 16. Okay, and this one also has an area of 16 because we know that 8 times 2 is also 16. The last one has an area of 16 because we know that 4 times 4 has an area of 16. Let's bring it back to arrays. So I filled up the shapes with circles, and you can see that the arrays and the rectangles are basically the same. So for example, if I count the squares here, okay, you'll have to take my word for it that there are 16, right? Because 8 times 2 is 16. Let's look at this one for just a minute, just to mention something. This one here is a square. We know that because the length and the width are equal. Now, if we think about the array, okay, there's 4 going this way for the length, and there's 4 for the width. Any number times itself is called a perfect square. Now, why is it called a perfect square? Well, because first of all, when you draw an array, the length and width are the same. But also, a perfect square means that you're taking a number and you're multiplying it by itself. So 4 times 4 is 16, right? So you're taking a number and you're multiplying itself by itself to get a product. And that is called a perfect square. So I want you to keep that in mind. Could you think of other perfect squares? Let's take a step away from drawing diagrams and use our minds to come up with lengths and widths. So here's the same style of a question. It gives you an area, so the table has an area of 64 decimeters square. And we want to know what are the possible lengths and widths of the table. So basically what it's asking you is come up with numbers that you can multiply together to equal 64. So any answer we come up with is going to be 64 decimeters square. Okay? So the first one is pretty easy because we know that I could take 64 and I could multiply it by 1 and I'd get 64 decimeters square. We also know that since the length is so much bigger than the width, that this is going to be a very narrow table. Okay? Now, 64 I notice is an even number, so I know that there's 2 more numbers, or that basically the number would be cut in half. That something times 2 would give me 64 decimeters square. And you probably know that 32 is half, so 32 times 2 would give me 64 decimeters square, or that the length would be 32 and the width would be 2. This is also a very narrow table. Let's keep going. So I know that I can take 4, and if I take 4 and I multiply it by 16, that I would also get 64 decimeters square. Okay. Now, that means that the length is 16, the width is 4. As we keep going, we're getting a table that's less and less narrow, but still, the length is quite a bit larger than the width. Finally, I can do 8. So 8 times something would give me 64 decimeters square. Well, it turns out that 8 times itself would give me 64 decimeters square. Now, I want you to remember what I said before, that when you have a number and you're multiplying it by itself, that is called a perfect square. So that means that this shape here, if I were to draw a diagram, I would come out with a square because the length and the width are the same. Let's review what we discussed in this video. So the first thing we have to keep in mind that the area is of an object is a two-dimensional measure. Meaning when we measure area, we're looking at objects that have two dimensions, and that those dimensions are a length and a width. Yeah, I want you to keep that in mind when we do volume. The next thing I want you to pick up from this video is that finding area has everything in common with multiplication. So when we draw rectangles, we can also represent these rectangles as arrays. Now, why don't we see them as arrays? Well, because sometimes the numbers are too large. So if you have a room that is 18 meters by 12 meters, that's a lot of circles. But you can draw an array to represent a shape and to find its area. Lastly, when the length and area are the same, then this has come up, you have a square. A perfect square means that you can multiply the same number by itself to find a product, or the area. So when we think of the perfect squares, that really brings area and multiplication together. Okay? So keep these three in mind and think about them, and you'll understand area much better for the next videos. Can you find the area of the following squares and rectangles?